Hi everyone. Today we are talking about the law of conservation of energy. This is a pretty quick video, and then you're going to go and do the Google form that's attached. All right, some quick review first, because I want to make sure we really get these units down. So velocity, remember, is just like speed, but with a direction. Velocity is how fast something is moving. The units that we use for velocity in this class are meters per second. But you might see miles per hour or kilometers per hour or meters per minute, basically any distance per time. But we're always going to use meters per second. Kinetic energy is the energy of movement, and the units are joules. And then potential energy is stored energy, and the units for that are also joules. And a reminder that there are lots of different types of energy. We've only looked at a few of these, but you've seen all of these in some way. So thermal energy, kinetic energy, potential energy, electrical energy, light energy, and sound energy. All right, make sure you're taking notes on these next couple of parts. The law of conservation of energy says that energy cannot be created or destroyed. So remember, in science, we have laws that have been proven true over and over and over again, so we've kind of accepted them as truth because there is so much evidence supporting them. All right, so energy cannot be created or destroyed. On the other hand, energy can be transformed into different types. So something that started as kinetic energy can change to potential energy. Or another example, when you rub your hands together for warmth, you are transforming kinetic energy, because you're moving your hands, into thermal energy, because your hands are getting warm. I'm going to go through a couple more examples, because that's what the homework is going to be about. So when an item is dropped from up high, potential energy transforms into kinetic energy. So that works like that because we know that something that is high has potential energy. And then once you drop it, it starts moving. That's getting kinetic energy. So all the potential energy is transforming into kinetic energy. And then another example that we haven't looked as closely at, if you flip a light switch, you are transforming electric energy into light energy. So the electricity goes to the light bulb and it changes in the light bulb to light energy. All right, and then one more example that will come up on the asynchronous work. So take a look at this image. At point W, which is when the roller coaster is just at the very top, just starting off, it has potential energy. It has 400,000 joules of potential energy. It also probably has some kinetic energy because it is moving along. Then it goes down the hill, and at point X, it only has 40,000 joules of potential energy. So it starts off with 400,000 joules of potential energy, and down here it only has 40,000 joules of potential energy. So the question is, what happened to all that potential energy? The key point here is that we know that it was not destroyed. The law of conservation of energy says that the energy cannot be created and it also cannot be destroyed. So we know that whatever missing energy we have here was actually just transformed into some different type of energy. One type of energy that it was transformed into was kinetic. You guys know that because as it goes down the hill, it's going to be moving faster and faster and faster. So it's getting more and more kinetic energy. And it's losing all of that potential energy because it's not as high up anymore. It also, as it's going, is making some sound energy. If you've ever been on a roller coaster, you know they're super loud. So it's making that sound energy from potential energy. And it's also making heat energy from the kinetic energy. So when the coaster is going along these tracks, the tracks are heating up a lot because of that kinetic energy going across them, transforming into thermal energy. So those are some different examples. If you get to a question on the homework that you're confused about, come back to this one and re-listen to that explanation because there's multiple parts that you should be paying attention to. All right, I'll see you in class.